imagine you are an alien, you are an extraterrestrial being that is trying to understand your code, and you are trying to understand it without knowing the context, without having any preconceived notions about the code. Hello everyone, welcome to Testeroni, where I help the QA specialists become test automation engineers one slice at a time. And today we are going to talk about a universal experience that sadly concerns all of us in our day-to-day work. So when you're starting out, having your code, your thoughtfully thought through code, your heart and soul suddenly fail on you is one of more disheartening experiences. Like, you have thought through the whole process that this test case goes through, and then you see that it fails and you don't know why. So it's no wonder that it is a troublesome situation. However, it is also a good place to learn more about your code, about the framework, about the tech stack, about all those things. So in order not to be caught off guard in such a situation, and in order not to stumble in the dark, we're going to talk about a little system for that today. Because regardless of how deep within the field you are already, whether you are just learning, whether it's a hobby project, whether you are actually doing that in your day-to-day job, this situation is going to arise. And it is going to be an everyday struggle. And so in order to combat this, you need to have some set of rules or actionable steps that you can just go through so that you are not stumbling in the dark, like I've said a moment before, so that you are not scratching your head too long over something that may very well have been prevented if you just decided to go with a scenario of sorts. So today we are going to talk about exactly such a system, and we will use an abstract idea of an end-to-end test that you may have developed as an example for all of further discussions. So let's dive right in. Let's say that you have created an end-to-end test and suddenly it's failing on you. It's just giving you red and you don't know why. You don't know where to start. So in order to tackle this, first of all, always check the logs. So the logs are exactly a mechanism for such a situations. They are there for a reason. They are there to help you. And so just dive into the logs and see what you got. Wasn't an error, a warning? Is there some syntax error perhaps? Just go through the logs and see what actually the culprit is according to the logs. And of course, this may not solve our problems already, but this is always a good first step. Just check the logs. See if there even is something that looks like an error, because maybe it's green. Maybe the logs say that everything went well and still the test is not behaving like you thought it would. And this is also an important caveat. So the logs just inform you about how the execution went. So the logs are great at many things, but one thing they still cannot do, sadly, is read your mind. So a green log does not mean everything is working fine, as we understand it, as humans understand it. It means the instructions that I was given, I being the program, the instructions I was given were executed properly. So if the instructions were wrong in the logical way, it will still be green. So you will still see a green report, but that does not mean that everything went well. It went well as far as execution is concerned. But if you provided it the wrong instructions that do not do their job at actually testing, then even though it's green, it's not the kind of green that you think it is. So a green log just informs you that it has performed what you programmed it to perform, for better or worse. Number 2, get rid of the syntax errors. So if after checking the logs, it turns out that there is any kind of syntax error, this is the first thing that you need to focus on. So you can't really move forward with syntax errors in place. If you stumble upon a syntax error, be it a typo or something is out of range, problem with the indices, with the namespace, something can't be found, you used a function that is not called what you thought it would be, regardless, if there is a syntax error, this is the very first thing that you need to fix. Thankfully, this is also always, or most of the time, the simplest things to fix, because this will most often be something with the naming or something like that. Either way, if you have syntax errors, you should tackle those first. And after you do that, we go to point number 3. So hopefully you have removed the syntax errors, so you can do a full run of the test now, a full execution, and now you should look again at the logs. Just be mindful that you can never look too much within the logs. They are there to help you, and many times they will inform you of something that you would have spent a lot of time trying to figure out on your own. So utilize this functionality. And if you have fixed the syntax errors, just dive into the logs and see what you get now. If there used to be a syntax error and you thought that you fixed it, rerun the test, check the logs. If there's another syntax error, redo this thing. So you may be stuck within this loop for some time, because maybe you have fixed the syntax error and now there is some other computational error, like an index is out of bounds or something like that. So you just need to fix those things one by one and rerun the test and recheck the logs and see what they actually tell you. It is actually helpful to run the test and see the logs at every step of what we're going to be talking about, but especially in this beginning stages when you are just getting rid of the most obvious things, because this is also where you get the most bang for your buck. So this is the place where you actually are going to have the most value out of rerunning the test and rechecking the logs. So just go ahead and rerun the test and recheck the logs. So we have rechecked the logs. There are no syntax errors anymore. So let's try and understand what the logs tell us. And I would say here is where the things branch out a bit. So first of all, like I said, check for whether the logic behind it is sound, because we are now free of the syntax errors. Hopefully we can run the test, but is the logic actually sound? So when you check the log, when you see the list of steps, the list of screenshots, it depends on the framework you are using and the instructions provides it within the configuration, but just check it and see what actually is going on. Does it perform the actions you thought it would, or is it just green because it is programmatically correct, but it's not checking the right things? So another branch of this point is, if everything is programmatically correct, do you see any errors regarding the testing aspect itself? So common things to look out for would be, for example, an element not interactable error, that you are clicking something that is not interactable, to see whether there are no race conditions, so that something is not loaded up properly before you start trying to actually test it. Something is out of bounds. So for example, you haven't scrolled somewhere so that you can actually interact with that element. Are all of the clicks coming through, and are they actually clicking what you thought they would? Are all the locators in place, and are the correct locators being utilized? Maybe you need to recheck the XPaths or whatever method of locating elements you are using in this specific spot. So these are all common problems, warnings, errors that you may see when you actually dive into the testing aspect of the code, when the syntax is right, when you can run it and you are not getting problems with the naming of the functions, for example, anymore, but you may start seeing problems with the workings of the testing side of that. So as you can see, at this moment, there are a lot of things that may go wrong. And there are a lot of problems that you may locate right now. And this, sadly, is the good scenario. That may have sounded like something pesky and problematic, but to be honest, this is the good scenario. The bad scenario is when you don't find what you are looking for, so the reason for the bug at this stage. And this is not really uncommon, sadly. So if something was amiss here, it's a pretty easy fix, right? Like, if there was a problem with the syntax, you fix the syntax. If there was a problem with some logic, you fixed the logic. You tried to fix the logic. If there was a problem that an element was not loaded up, you added a wait or something like that. This is pretty straightforward. but many times you won't actually find what you're looking for at this stage. And in such a situation, we need to go to the next point, which is number 5, read the script as if you were an alien. Some people may call it rubber duck debugging or something like that. I like to use the UFO analogy because rubber duck, I think it kind of misses the point of a sentient being trying to make heads or tails from what they're saying. So I like the alien approach. So imagine you are an alien, you are an extraterrestrial being that is trying to understand your code, and you are trying to understand it without knowing the context, without having any preconceived notions about the code. You are not reading it like in huge chunks or blocks as if you are a creator, a developer of that test. This is what you are doing. But now you're an alien. You are not doing it like that. You are going line by line, reading everything, not having any assumptions, not understanding what things are doing. You go down the rabbit hole of every function and every variable, and you are just reading it as if you were seeing it for the first time and not understanding what the workings are, how the cogs actually intertwine and interconnect. So you are trying to get rid of everything you know and believe about the code, and you just go through it as if you were seeing it for the first time, not knowing anything about it or anything about the more architecture knowledge you can also drop while doing this is also for the better. So without also knowing the architecture or the stuff surrounding it. Don't assume anything and just go through the lines one by one, go through the instructions and try to build the mental image of how it should be working from the ground up. You remember, at this stage, you are not the creator of this test anymore. You are trying to build it anew. If this still hasn't helped you to find the culprit, you now need to add some sleeps so that you can observe the code in action. And I am using sleeps figuratively here. You don't need to use the exact sleep instruction. You can just look at how the code is performing in real time in the automated browser, for example. But adding sleeps very often is kind of useful because things go very fast if you don't. And you may not be able to observe all the key points within the script. But you can also use, like, I don't know, weights, or you can use a screenshot function so that the framework actually provides you screenshots of every step along the way. The main idea within this point is that you need to be able to stop at the crucial parts of the test and see what it is actually doing, because you may be very surprised to see that what it is doing is not really something you kind of forecasted it to do, and it is not something you see within the logs. It is not something you thought it was doing. When you are actually seeing the clicking and you're actually seeing what your code is trying to do, only then you actually understand what it's trying to test. So just add some kind of breakpoints or sleeps or whatever method you feel the most comfortable working with and is synergically the best within the context of your framework, and just observe what it's doing. Because it's one thing to understand what the test is or should be doing, and it's a completely different ballgame to actually see what it is doing. So still, there's a problem. Okay, let's go to point number 7, which is check the repo for similar tests. And by similar, I mean they can be either similar by the actions performed. So for example, they are doing the same thing. They are doing like a manipulation of a specific hierarchy or a specific type of elements, or by nature. So for example, they are browsing the same set of pages. They are also doing the login, for example, or something like that. Try to find similarities in both of these domains and try to check the tests that do work within those same domains. Try and see both the tests, like I said, that are just doing the same actions and those which are actually targeting the same part of the application. Because you would be surprised that for very, very many organizations, there are such hacky solutions under the hood that you wouldn't believe it, seeing from the outside. There's so much bubblegum used to glue things together, and there are such silly workarounds utilized sometimes that you would have never figured that out on your own. So there were people before you that have already scratched their heads over this, and they have already pondered this and had long discussions and long periods of despair over not being able to actually fix something or code something up. So there's no need to reinvent the wheel. It's always better just to reuse what the giants before you have already coded up. Plus, like I'm saying, very often it's not really a logical solution. So it's not something that you should have figured out. Maybe there is just a workaround that is there in place for some time. It is kind of technical debt category, but you have to roll with the punches. So if that's how it's structured and you just need to create a test, maybe you just need to stick to what works, whether it's hacky and workaroundy or not. So just try and check all the similar functions, check all the similar tests, and check all the similar files regarding the same or samey parts of the application. Because maybe there is some code you need to inject. Maybe there's some custom library you need to use. Maybe there's some custom function. Just never underestimate the degree of workaround wizardry that may be going within the code underneath. So just check it and don't beat yourself up for not being able to come up with it yourself, because very often it took some time to develop this workaround solution and you just need to utilize it. Number 8, take a break. And I know this may not be something that you would want to hear. We do get the tendency to hammer away at a problem until we find the solution. But in many situations, if you have already tried all of these things that I have mentioned, you'd be way better off if you could just work on something else or take a walk or sleep on it, whatever is feasible for the situation, rather than trying to stare at the screen, just frustrating and getting your mind into a more and more compressed space and not being able to see any outside of the box solutions. So I know you may think, you may rebel, you may say that, oh, Casper, but I'm already in the zone. I don't want to get now all fuzzy and forget what it's all about. I'm in the good spot. It may seem like this, but trust me that in many situations, you'd be way better off just trying to decompress, trying to get your mind off of it, and just thinking about other stuff. And you'd be amazed at how often things will just come to your mind. And very often it may not even be a solution to your problem. It may be an idea on how to actually rephrase the problem, on how to actually create the code in a different way that doesn't even have the problem you are facing now anymore. You can just run around it. So why try and bang your head against that wall trying to get through it? Just have a little break, chill for a moment, and I'm sure that it will be useful too. Number 9, talk to someone that may know the answer. So at this point, you can actually always use beforehand, because if you know that your good colleague has already worked with this specific part of the application, may have come across this specific issue, there's no reason to bang your head against the wall and just wait for it to be the time for number 9. But very often I feel like number 9 is a good spot to place it within this hierarchy. So just, if you are still at a loss, think of people that have worked with this or have worked with similar stuff or are just knowledgeable in the code base, or maybe someone that you just like doing brainstorming with. Maybe a quick hop on a call will be enough with screen sharing to get a fresh set of eyes to look at your problem and to actually provide some outside valuable insights. Maybe just having outside input is enough while you are so submerged within this issue to actually see something from a different perspective and find the solution. If it is not, however, we go to number 10. And number 10 is to ask on public forums. Of course, adhering to your company's policies. So rather than just copy-pasting your code, which is both not really the best way to go about it and probably illegal, I'm actually suggesting you to create a minimum reproducible example, so a short snippet of code that shows the nature of the problem you are having rather than copy-pasting the problem itself, and then just going around and trying to ask people online. It may be on Stack Overflow, it may be on Reddit. Regardless, you may choose your flavor of assistance, but by doing that, you are getting the world's top experts to look at your code, and once again, you are getting an external input within your problem. However, like I said, I can't stress enough, create a minimal reproducible example. This is the way to go. First of all, like I said, because you are not really permitted to take the code from the organization outside of it. But secondly, because this way you are showing the nature of the problem. You are not really just throwing 100 of lines of your code and at people and expecting them to kind of magically infer something from that. You are cutting all the fluff, and you are just leaving the important stuff and showing them something that they can run on their machines, not a corporate machine behind a VPN with 10 layers of architecture on top of it. They're actually able to run it on their own. And even if you are not yet doing test automation on the daily, you can actually do it even when you are doing your hobby projects. Then still try not to just dump all your code on people. Try to think of a minimal reproducible example that you can post so that people can quickly see what you're trying to do and quickly provide assistance. And these 10 points should be enough to actually pinpoint a problem within your test. If these are still not enough, there may very well be a problem with the architecture, the application, the framework, the suite itself. So there may be a problem with the limitations of the architecture itself. There may be a problem with how the application is functioning and stuff like that. Just then try to communicate it to your team. But then you are sure that this is not something that may have been easily prevented or fixed. So don't treat this option as a get out of jail free card. It's not something that you should jump too eagerly to. It's not a conclusion that just allows you to have your hands clean and not really have to work with the problem at hand. No, I'm just saying that if you have performed in good faith and with actually trying to find the problem, all the steps beforehand, there is a non-zero chance that you have actually stumbled upon something that is not something you can fix in the code. Maybe it is something that is completely out of your control. This is the last resort, and in the vast majority of situations, there will be a solution that you will come across while going through the steps beforehand. But if there isn't, it may very well be that you have actually stumbled upon something that you cannot fix. Please also keep in mind that this is not set in stone. Even though it is a set of 10 commandments, it's not really on a stone tablet. So you can rearrange as you see fit. So if you know that your good colleague has been working with such a thing, you don't need to wait for step number 9 to actually contact them. Just use your common sense. I think that this kind of arrangement of these points kind of assures that you are doing things in a sensible order, so that you are not running around in circles and not checking the same thing thrice. It also allows you for getting assistance in the fastest way, and it allows you to be the most efficient in actually finding the culprit. And this is what it's all about. Like, why would you be digging deep within the framework for other examples of such tests when you haven't yet fixed your syntax errors? And similarly, why would you waste time trying to produce a minimal reproducible example that is also anonymized, posting it online and waiting for the answer for who knows how long, when you still haven't checked your locators? So this just makes sense, and it's also when arranged in this way, it also maximizes your skill growth, because it allows you to try and fix stuff on your own. And actually, problem solving is one of the top skills you can have as a test automation engineer. So try and solve problems. And I'll be frank with you, debugging your tests very often is kind of a tedious and really boring task. So there will be times when you will feel like a detective on the case and fixing stuff will come with a great feeling of accomplishment. But in a lot of situations, you'll feel more like a trash digger. And fixing the problem will actually come with a sigh of relief rather than a gasp of accomplishment. Either way, those problems do need to be taken care of. And I hope that by employing such a list, such an algorithm for solving these problems, for using these 10 commandments to actually try and fix the problems you are having, I think that this will actually be helpful to you so that you can minimize the time spent debugging and maximize the time you have for other things within your project. And also conserve your sanity while doing all of it. So I hope that this has been helpful. Thank you for your attention. Please check Testroni on YouTube, Facebook, Instagram, wherever you can. And if you have any problems, comments, questions, just go ahead and leave a comment underneath. If you have any topic for further episodes that you would like to hear about, then also feel free to leave the comment. And in the meantime, I hope that this list will prove to be useful for your endeavors within the test automation world. Thank you once again for your attention and keep on rocking.